Ever wondered what makes an electromagnet tick? How does a seemingly simple coil of wire transform into a powerful magnet with the flick of a switch? Today we unravel the science behind this marvel of electromagnetism. Scene script. Imagine a coil of wire. It might seem ordinary, but it holds the potential to become an electromagnet. The magic begins when we introduce an electric current. Introduce electricity into this coil by connecting it to a power source, perhaps a battery. As the electric current flows through the coil, it generates a magnetic field around it. Picture electrons, the carriers of electric charge, moving through the wire. As they journey along, they create a magnetic field. This is the heart of an electromagnet. This magnetic field is not too different from what you'd find around a permanent magnet. It has direction, which depends on the direction of the electric current flowing through the coil. Think of it as the compass needle that aligns itself to the north and south poles. The magnetic field is strongest at the center of the coil and weakens as you move away from it. The strength of the magnetic field can also be controlled by varying the amount of electric current flowing through the coil. Now, what sets electromagnets apart from their permanent counterparts is their ability to attract magnetic materials such as iron and steel. Once the current flows through the coil, it behaves just like a magnet, pulling these materials towards it with an invisible force. But here's the catch. The magnetic field exists only as long as there is current flowing through the coil. Turn off the current, and the magnetic field disappears. The once mighty electromagnet loses its power, and the attracted metal objects simply fall away. To recap, the workings of an electromagnet are quite straightforward. It all starts with a coil of wire. Introduce an electric current, and a magnetic field forms around the coil. This magnetic field has the power to attract magnetic materials. But remember, the magnetic field is temporary and dependent on the presence of the electric current. And there you have it, the fascinating inner workings of an electromagnet, a testament to the beautiful relationship between electricity and magnetism, and a reminder of the wonders that science holds. Dive into the world of electromagnets and you'll never cease to be amazed.